Today we do something a little different. We program. That's what we're going to... Okay, so we're not doing anything that much different. Actually, we are a little bit. So we're going to mess around here a little bit, doing some random programming. But then we're going to focus on system design. And we're actually going to do some system design interview stuff. So, yeah, we'll do all of that. So, that's what we're going to do today. All right. There we go. There we go. Okay. So yeah, today we're going to focus on system design. We're going to talk about, well, we're going to talk about a couple things. One, I want to talk about the system design of Eddington so far. I kind of been struggling with myself with, I don't like it. But I'm not certain that it's bad. I have a couple things that I dislike about it, and I want to talk with you guys about it, walk through it with you all as it is today. And kind of what I'd like to see. Some of the features that I'd like to see. I don't actually have answers yet for those things. So we'll talk about it, and then we're gonna move on to let me pull this up. You know, and something I want to do is I'm gonna get somebody on here to actually interview me. I have to get somebody that's good at interviewing that I know. Get them on here to interview me on some of these things, but I worked this week to make these. Let's see. So we have the system design here, and under our live streams, all organized. And what we're going to do is we're going to just do some of these. So these are basic questions that you would have for system design interviews. Today we're going to talk about design X questions. So like you'll get design a cache, design a delivery app, design a messaging app, design a social media app, design a URL shortening. You'll get these. These are, I think we'll probably do the social media one. This one's a pretty standard one. Design Twitter, design X, design, something like that. It's a pretty standard one. So we'll probably go through and do this. What we're going to do is actually type up everything, kind of like a blog post, but we're going to put Excel-a-draw in there and everything as we walk through the problem. How would I design it? I will also go over my basics of design X interview questions and review those. We'll probably fix these up a little bit. So those are some of the things we'll do today. Hi, how are you doing? How are you going to do... Wait. How are you doing? Do you stream on other platforms? Oh, I'm doing well. Thank you very much. And this streams to Twitch as well. Let me show you. You can watch on either platform. Whatever one's best for you is generally how I do it. I was going to pop out these chats so we can put all chats right over here. I can't pop out Twitch chat really quickly. 1 second. I can pop out Twitch chat. I just have to get to it. There we go. Throw that on 5. Boom. There. Oh, there we go. Here's our chat. So, yes, I do. If you're wanting to know, it is on YouTube. Everything is everything equals this null labs. So YouTube Live would be my live channel on YouTube is null labs live, and my main channel is youtube.com/at null labs. Null labs like that. My Twitch is twitch.tv/merit counts. Why not null labs? I'm not really sure. Not entirely sure at all. You guys will just have to deal with it. So yeah, that's what we're going to do today. I know that we've been building a cloud, and that cloud is called Eddington. I wanted to do basically a system design review of it right now. And talk about where it needs to go. I'm not happy with some of the stuff. I'm not happy. Let me tell you what I'm not happy about here. To start doing anything with this, you have to first open up Zellige or Tmux. You have to have a you have to have a Ori account, and you like there's a lot of you have tos. So you're gonna have to have some terminal multiplexer, or just open a bunch of tabs on your terminal. Either way, that's not entirely fun. I know that we're trying to solve a complicated problem. So this is the other issue, is I know that we're trying to solve a complicated problem. So like there is going to be some inherent complexity in that, but I feel like I adopted too much already. I feel like I adopted too much complexity already. And so we're going to review that. The other thing that I dislike about it is how the authentication works well for the front end at this point. Got that kind of under control, but I also don't want you to need to have a Ori account to play around with and dev on Eddington. That's kind of an implementation detail for me. And so that's where the system design comes in, is we got to design it some way where that implementation detail for me doesn't affect the open source project. Right now it does. It doesn't have to be my Ori account, but you have to have an Ori account, or you have to have Ori set up somewhere. And that could be, we could add the implementation detail of just installing Ori on the server, like in the deployment. That's more stuff. So I don't know. I was kind of hoping to remove users from it. But that's also difficult. So yeah. So yeah, and then I was figuring that we have all of these things that we can go through and do, and you know, you guys get to pick. We don't have to just do system design stuff either. We can do other interview type stuff or educational stuff. So these were kind of things that people would really like to do for like interviews and stuff, but they don't have to be like interviews. If you're just asking, if I was in a system design interview, these would be the things I would expect you to know. Maybe there's some other stuff. Maybe you are in an interview and have a weird thing that you'd like to have discussed. Bring it up. We'll knock some out this year. We'll just do one of these every once in a while. I think the sequencer is very interesting. It's a little bit more challenging. You know what? Another one that I would expect of rate limiting. Rate limiting is going to be another interesting one that we'll do some stuff with. So, how to build a rate limiter. There are ways to do it. Is the cloud you're building, is it a LAS or a SaaS? It's a Lassie SaaS. It's a Lassie SaaS. Oh, wait. Was that a... Wait. One second. Was that a LAS or an EAS? Was that an I or an A? I can't tell. One second. I got to copy that over. That's an I. My bad. It's an EAS, not a LAS. It's that too. So I mean, it's AWS. It's AWS. But let's start with it. So my problem with our cloud is that we're trying to solve a complicated problem, and as complicated problems go, I think I maybe jumped a little too hard into the complicated. Now, maybe we need to write some code to make it simpler, but right now that's not how it is. Let's see. Today's date. We'll put that in there sometime soon. Okay. So this is actually the architecture. Let's just make this as current architecture. We'll make this a living document. We'll also throw this into the README when we're done with it. We'll do some canvases and stuff. Let's folder. This is just markdown anyways. And this way we can do like a new canvas and start drawing around. Okay, so what are our goals? Our goals are to provide infrastructure as service. Goals. Infrastructure. As a service. But one of the things, if you've been around at all, is I hate that you need to use infrastructure as code. I absolutely hate it. So another goal is not need IAC. So to do this, we can talk about how you need to do this, but yeah. Not need to know how to build containers or VMs. The reason it's also a SaaS is because to do these things, we provide things as a service, software as a service like Kafka or NATS. Without you even needing to spin it up. I have a space in here somewhere. There we go. So yes, it's a ES SAS LAS. Probably a hassle too. Wait. What are you asking why to? Why what? Sorry, I don't always read. I don't read chat exactly. You know, which one? Not need infrastructure as code? That's probably the most hot take that I have. Is that infrastructure as code is bad. And don't get me wrong, I use infrastructure as code. It's the best tool we have right now. It just sucks. Why licensing? I just figure that one thing that you could provide is like other things, which would be like licensing. If you're talking about the LAS. Yeah. Maybe. We're focused on infrastructure and software at this point, but yeah. All right. So I don't want you to have to worry about this. It should support monoliths and microservices. Event-based with no extra work. This is kind of where the SASE part is required. Again, you're going to get nats.io connecting everything for free. Status page for free. I don't know why other clouds don't do this. I don't know why this is not just something. Status pages are hard to make. Stop making us make them. Very few people... Yeah. Status pages are actually hard to make well. Because your status page can't be down when your stuff is down. So to make a legitimate status page, it takes some extra work. 1 second. I was wondering why I was getting so hot in here. The basement's chilly, so in the morning I turn a little heater on. I left it on. I usually only leave it on for like 5 minutes. I was like, man, it's getting hot in here. Whew. All right. My goodness, I'm a little toasty. Oh. All right. So these are kind of our goals. So kind of the base requirements here is I need a way to build their code. So this is really important when you're talking about your system design interviews. And we can look here in our, let's actually pull this up. When you're doing system designs in interviews, one of the most important things you can do is ask questions. Ask questions. If you don't go through a system design interview asking questions, it's a fail from me. And the reason it's a fail is because part of system design is actually you getting to the bottom of what you're actually supposed to be designing. And if you're not asking questions, you're not actually getting to the bottom of what you're actually supposed to be designing. These questions are a lot of times vague on purpose. We don't have, this is supposed to be X as like unknown, not design X, like the platform. We'll do Y, design Y interview questions. So ask questions to get the requirements. So we're going to get the requirements. The base MVP requirements here. MVP. Given X git repo let's see, given not X, but we'll say Go, JavaScript, TypeScript. Actually, that's not entirely true. This is Express. Given an Express, or given a Next, React. There's another front end we support building. Yeah. We'll just group these as UIs. Although I know that Next is also not fully a UI. We'll talk about more about that. Go, Express. There's also Rust. I think those are the ones we support at this point. Git repo. We're going to build it. Build a container image. Be able to run that container somewhere. What's up? Hey, everybody from YouTube. You're way more chatty than the people on Twitch today. Usually it's the other way around. It's good to see you, YouTube people. What are you talking about, Vue? I have Vue. I actually, that's... Oh, you're saying we should be able to run Vue. Okay. We'll add it. We'll add it as a thing. We'll add Vue. No problem. So we have a CDN. We can actually run any of these as long as you compile it. I don't have compiling everybody's front end frameworks yet. You know, that's something we can do, but right now the design for this would be if basically you could do something like this, where if you have two branches, like your main branch and a deploy branch, and we'd watch the deploy branch for Vue, and as long as you built and committed that to the deploy branch, you know, we would be able to run it. Or if you did it in a folder inside the main branch. There's a couple ways that it can be supported today. That's not as nice. I get that that's not as nice. But yeah. So, okay, we'll put Vue in there. That's good. So the front end is actually currently in Vue. I suck at Vue. I haven't ever used Vue before. I've only ever used React because I like getting paid. I'm sorry, Vue people. But I've only ever used React, so I'm really bad at Vue. I'm really bad at Vue. What's up? How are you doing? Okay. So we're going to be able to run that container somewhere and expose it to the internet. For everybody just joining, we are doing system design today. We're talking about Eddington system design right now, and then we're going to jump into system design interviewing questions. Again, join the Discord if you'd like to ask questions. I'm going to be trying to do one of these, a couple of these a week throughout the week, just taking one of these and actually sitting through on a live stream, designing it as I would in an interview. If you know somebody really good at interviewing, I don't mind if somebody comes on and interviews me and asks me some of these questions, if that would help people. We can do it a real interview, and then we can go back through the interview and discuss it. You know, I'll make mistakes. I'm not perfect. I'm actually terrible at interviewing. You talk about somebody that gets nervous interviewing, that would be me. I forget 3/4. I only interview with 1/4 of my total knowledge. That's I walk into an interview and 3/4 of it's gone. So if they like what they see in the interview, they're only seeing 1/4 of it. Yeah. So where is the Discord link? You know what? I have not set up YouTube very well. I will get a Discord link in YouTube, but for those of you watching today, let me go ahead and get you a Discord link today. I'll post it in chat. Let's see. Invite people. All right, this one will be available for 7 days. Use it, love it. I will put a permanent link in the YouTube. So when I go live, in that description, there should be a Discord link. Sorry about that. But what I want you guys to do is if you come up across an interesting system design interview this year or think of one and like to have it discussed that we haven't covered yet, let me know. And we'll do it. I won't do them in Discord as much. We will, you know what, am I on streamer mode? So I shouldn't be getting pinged, right? That would be terrifying. I didn't have my headphones on. If I am pinging people, I'm going to apologize. I don't hear it, so hopefully I didn't. All right. I will put on some music. Couldn't have my headphones on because it's so hot in here. My goodness, I was roasting. Wasted so much electricity. Did not mean to do that. Oh, good. And I am in streaming mode. All right. Get a little music going. Actually, you know what? While we're doing these, maybe music, that's more like a coding thing. We'll save music for a coding thing. We'll save music for a coding thing. But we got it ready. We got it ready. Whenever we're getting to some coding. All right. Expose it to the internet. For the MVP, we're not actually going to let you bring in a custom URL just yet. But you should be able to bring in your own domain eventually. Bring your own domain eventually. Obviously, you can always point your DNS to whatever, URL we give you, but there's so many things you can do with this. Okay, so expose to the internet via custom. I think your URL. Okay, so build a container image, be able to run that container somewhere, expose it to the internet. This is our MVP, but in the future, things that we know that we want to support, things we know we want to support is Nats or Kafka. So we want to be able to support Nats or Kafka for message queues between. So this is a little bit of software as a service. We want to support a database. Simple database. This could be like a third-party software license thing. Not sure. I really want to do... See, database as a service is a serious topic because then you're storing somebody's data. Microservice goes down, fine, whatever. But your database has to be solid. And I just don't know that I have enough time to provide a solid enough. So probably third party, but we'll see. Simple database. Let's see. What else? What else? User management. So if you didn't have to deal with users, what if we could even terminate the users before you got to them? So you don't even have to put auth in your application. Yeah, I know that sounds crazy, but this is the type of stuff I want to tackle. This is the type of stuff where it's like, what if I could have authentication and authorization, and it doesn't even have to be part of my app? Can we do that? I mean, it sounds crazy difficult. Don't get me wrong. But can we do that? I think we can. I think we're there. I think you should be able to say this service requires authentication, and it has authentication. That's what I think we should be able to have happen. All right. So let's draw this up. Let's draw this up. Now we could do a new canvas, or we could do a new drawing. I've never tried the canvas. This is like built in to Obsidian, versus the drawing is 100% Excel-a-Draw. I'm going to try this really quickly. Add a card, add a note. This looks pretty cool because like you can do like this type of stuff. You know, we're gonna go with a new Excel. I don't know how to pronounce this. This. Oh no. Where's my dark mode? Give me dark mode. That was close. That was close. I think every canvas defaults to light mode. That's terrifying. Okay, whatever. Doesn't matter. Let's start with this. Is there a way to do the content delivery network for system design? Today, I could possibly. So there's, you know, real talk. I could probably pass a content delivery network system design question today, probably. But also doing it for educational purposes. Let me think if I'm solid enough, because I want to say that I'm not solid enough on that one. There's ones that I'm definitely solid enough. Social media app, URL shortening, API. I'm solid enough. Easy. Designing a cache, I can probably pass as a mediocre dev, not like a senior or principal on designing a cache. There's a couple things that I know that I should probably know more about. Designing Google Docs, I could probably pass as a mediocre dev for designing Google Docs, because like I know the keywords of some of the technologies that you would use to do the live editing together, where you could have multiple people editing the same document. I don't know the finer details of those things, so I don't think I would do it justice to do as a review. And that's where I am with the CDN. Doing it as an engineer with 5 years experience, I could nail it. Could nail that interview. Probably know more about a CDN than most devs with 5 years of experience. Could I do it and get a principal engineer job? Probably not. But that's kind of what I feel like I would need to do if I'm going to record an educational piece for people. If that makes sense. But yes, absolutely. I think I have a do I not? I don't have a CDN in here. Okay, well, let's add it. That's a fantastic one to do. Oh, I have a content delivery network. I didn't have it in Design X questions because, okay, we're going to put it here as well. So I think there's two aspects of this, because there's the design the CDN from a high level aspect, but there's actually unique aspects of a CDN as well. And I think that's where I was breaking it down here, where there's definitely unique aspects. So like any of these, there's databases. But I want to go over databases specifically. I actually have a video on databases about the different types. That one's actually coming out very soon, about when and why to use different types of databases. Like, don't just say that you're going to use a database. Tell me what database you're going to use in your system design and why you're going to use that one. It doesn't even have to be fully fleshed out and perfectly correct, just as long as you show the idea that you understand the differences between databases. But if people are really interested in the high-level design of CDN, we'll do it next week. I can freshen up on this easy enough in a week or two. I said next week, maybe 2 weeks. But we'll do this one soon. No problem. Let's keep track of that, what people want. Do I already have a to-do in here? I do not. Oh, I had a special character. Okay, to-do, let's see. Cool. Yep, let me know if there's anything else that you guys want, and we'll do it. We will do it. Okay, so right now, to hit these requirements, we're going to pull this up. Actually, can we embed this in here? I don't know if we can. Okay, yeah, but that's... I guess technically that embedded the dog, but it's not nearly as cool as this, where you're like, oh yeah, our current architecture is right here. My goodness, that's pretty cool. Can I draw in here though very well? Or is this just like... Okay. Okay. I think honestly for the current architecture, this is going to have some pretty useful things, but we'll just do it this way for right now. So to reach our base things, we have to run other people's code. And so to do this, I've picked Kubernetes, but Kubernetes I don't think is the best choice for this. I have a project called Legion that we really need to work on that I think actually would solve this better. It's closer to what Fly.io uses as well. And so yeah, I think we'll have to do more on that because Kubernetes is going to reach its limit. Now, right now we're going to build it on Kubernetes though, because that's the easiest way for me to get something working. Kubernetes, and basically we're using Kubernetes for its scheduler. That's effectively a scheduler, and there's one other thing that we're using Kubernetes for. How do I explain this? We're using it for a scheduler and for the custom resource definitions. So I'm just going to put CRDs because basically this is easy operators. That's what we're using it for. Easy operators. All right. So why I say easy operators is because without Kubernetes, you would have to have some way to persist storage across multiple nodes. Basically, Kubernetes gives you an easy, this is an API that has, etcd backing it, that comes to consensus. So it is easy operators. So that's what we're using it for. Now, I do think Legion will be a better for both of these things eventually. But this is what we're leveraging it for. All right. So on top of this, we have a couple things. We have something to build containers. And this is currently, if you look in here, this is the container builder. It's a separate service. We're kind of a microservice thing here, but we actually have one monolith. For better or for worse, this is the API, is the app monolith. It actually has the business logic and everything in it. I called it API because I suck at naming, and it has the API. So this is I suck at naming. It probably could be called Eddington, because like that's the, who knows what it should be called. It's called freaking API. This is called the container builder. You know what? We'll put their names as they are in the file system here. Container builder. Okay. So this is a lot of everything, and this actually all works as it is. So the scheduler, this right here actually is a easy operator. And then the last thing that we have that isn't part of this, we actually have one other thing here. And that is basically this thing here called the null operator. Yeah. So this is where I think I've gone a little too complex, but this is why we're talking about it. The null operator is another easy operator. It's obviously an operator, but what it does is it basically manages the execution of your application. So manages applications state on Kubernetes. It's also operator. So kube operator. So this is what it is at the bottom. So we'll just do type. It's a kube operator. This is a Go app. And you know what? When you're doing a architecture interview, you don't need to go into this type of detail. Now, I would expect if you said you were going to use Kubernetes, I would expect you to defend why you want to use Kubernetes. Maybe it's the right choice even. I still want to see you defend that choice. Just because I question something like, why did you pick Kubernetes? Why did you pick Microsoft? Doesn't mean that I think that you're wrong, but we'll get more into that. Right now, we're just talking about Eddington's terrible architecture. So I have a love-hate relationship with Kubernetes. I have committed very small amounts of code to the Kubernetes project. I actually like Kubernetes. But I also think that there's better ways. I think Kubernetes was a great first stab for the people that created it. I need to do a video on Legion. Actually, I can probably do that next weekend if you guys would like. Legion would be my Kubernetes killer based off of the We Are Legion. Kubernetes takes... All right, I'm going to go over here. We're going to do a quick drawing. We're going to do a quick drawing that we're not going to save. I need to do the video for you guys, but until then, Kubernetes takes this approach. You have this control plane, and this control plane does things. And these are all these things over here are the nodes. And it does things with those nodes. And these nodes are really dumb. These nodes are really dumb. All they do, the only thing they can do, is run whatever the mothership tells them to run. Watch this. I'm going to do this. Oh, killed it. Look at that skill. All right. All they can do is whatever the control plane tells them to do. And this is fine, but this doesn't scale as well. This is why you have companies that run multiple clusters. If you need to scale to over, 2,000 nodes, you start breaking up your Kubernetes cluster. And maybe you even do it at 100 nodes. And you know what? Part of me says that's fine. 99% of people don't need to go over 2,000 nodes. So just who cares? But this gives you one distinct Kubernetes cluster. If you want a second Kubernetes cluster, you have to do this again. And I don't like this. Now you're managing, some people manage 100 Kubernetes clusters. 100 Kubernetes clusters. But what if we built a scheduler, and really all you're getting out of this is a scheduler? Okay. But what if you built a scheduler off of promise theory? What if you built a scheduler off of promise theory? And instead of having this, and we'll label this. This is Kubernetes. This is Kubernetes. And I know I'm simplifying a bunch of stuff, but Kubernetes is effectively a scheduler that only knows how to schedule containers. Another problem I have here is, what if I want to run both containers and VMs? This gets hard. And especially with how Kubernetes is designed, it gets very hard to mix. Let's say this one can run VMs, but not containers. This one can run containers. And this one can run VMs and containers. Can we do this? Yes. It's not straightforward. It's not easy. It's not really the happy path for Kubernetes. So what I would like to do is build all of that. But basically, I don't like control planes. I don't like static control planes. Let's rephrase that. So instead, it would look like this. This is what Legion will look like. Now, there's still control planes, but there's dynamic control planes. So if you deployed an app, basically there is a small little control plane over here that asks who wants to run this effectively. Again, this is promise theory. And a group of things will, and the first ones to offer to do it that meet the things. So we could ask to run a VM. And now only the nodes that actually support running VMs will actually offer. So these are the only two nodes that run a VM. They're going to say, yeah, we'll run that. They're the only ones that have the stuff. The same way with a GPU and whatnot. This thing here doesn't need to know who has a VM. It'll ask everybody. Anybody. Doesn't care. So what happens then is, let's say, I'm going to highlight these as VM runners, the ones in blue, just to make my point. These are the ones that offer to make this thing. Instead of drawing all these lines, we're going to make this blue. These are the ones that are, and so they offer to do it. These will form a control plane group for this app, whatever this is. We're going to name it Tom. We're going to name it Tob because I can't type today. So these will run the control plane group, and if you need to expand out to this one, that's fine. But these will be the dynamic control plane. And if this one fails for some reason, for whatever reason, these two can vote for another dynamic control. So there will always be three running, or three that are acting as the control plane. This one, we'll make it orange. These two are just running the app. These three are the ones that have offered to manage running the app and scheduling and making sure that it's running with the correct number and whatnot. And when this will make a promise to this that it's going to run it. But obviously this one, it can run VMs, but it doesn't make the promise because it's out of space. It doesn't have the memory. It doesn't have the GPU because this workload requested a GPU. Again, we don't need a central place that knows all of that stuff. This will actually let us to scale to more things. But the other thing that allows us to do is instead of doing this, you can have two clusters in here for two different teams because you can just make them part of the same group of clusters. Because you don't need to do this multiple control plane garbage. So this is Project Legion, and this is what would underpin our cloud as well. Because the thing that this allows us to do is a lot of what we want to do in Eddington are these containers. When I build your code and run it somewhere, I just want to run it in a container. Okay, like that's easy, and that's all I want to do. So I want to run these things in containers, but there are some people who are going to say, hey, I want to run a VM. And if they want to run a VM, and I'm a cloud provider of any cloud, you should also be able to run a VM. That is how it is. Chowder Swore, how are you? Hola. Check it out. Unified chat. There we go. How's everyone doing? So, this is Project Legion, but we're not doing that because that's a whole nother portion of work to do. So we're not doing that just yet. We'll probably bust it out some later. But not quite yet. But so anyways, when I talk about it, this is what I'm talking about. Yeah. There's actually a pretty cool project. Let me see if I can't find it. Now, the person who was leading this actually died very sadly in an accident. I believe a rock climbing accident. But Legion was going to use this, the Aura runtime. And basically it runs different things. So you know how Kubernetes uses a container runtime? Aura would allow me to run a container or a container or a VM or whatnot. At least that was my understanding. Yeah. To remotely schedule processes containers. So this, instead of using something like, I could use the container runtime locally. But this will basically allow me to abstract that away and say that every machine can run any of these. Now, maybe we don't want specific machines running virtual machines. There's a lot of reasons you could do that. You could say that these two shouldn't run virtual machines because they're only for running containers for the users. For the users that are doing this or whatnot. Like you can separate them out that way if you like, and you should be able to do that. And it will be easy because effectively what happens is these will just not offer to run those things. They'll say, nah, nope, no thank you. Her streams were great. I didn't watch a ton of her streams, but yeah. I didn't watch a ton of her streams, but cool project. Sounds like each data plane has its own mini control plane. Yes, effectively, that's kind of what will happen. Is each data plane will have its own mini control plane. And this is the way the cluster will only worry about clustering. So we're going to build a modified swim protocol for clustering. And that's what the cluster as a whole is going to worry about, is clustering and making sure that everybody knows what nodes are in the cluster and are what they're doing. That will be that's kind of the design behind it. There's not worrying about each other. Then each data plane is going to build its own control plane, or effectively, yeah. And honestly, I said something out here is going to ask. This is going to be a user. And when they ask, they're actually going to ask any node. They're going to pick this node. And this node's going to be like, I only do containers. My answer is no, but I'll ask the nearest ones to me. So I'll ask this one, and I'll ask this one, and I'll ask this one. And, this one says yes, but obviously we need more. So I'll ask some more. And so this one asks this one, and this one, and this one. And, these all said no, but we'll ask our nearest ones, and this one asks its nearest ones. And now we have our 3, and we return back to it. So basically, you should be able to hit any node in the cluster and act like it's the control plane. Whether it does what you want or proxies your request is not really relevant to you or important. Now, if you then ask, how's my deployment? How's my deployment here? And this is where the swim will come in. How is my deployment? Let's change this to blue. No, we already did blue. I don't want to use green because green makes it sound like it's good. That's not what I'm saying. Okay, so how's my deployment? And you ask this node right here. What's going to happen is when these say that they'll run the deployment, that will be communicated across the swim protocol. We can also mathematically prove that up to 1 million nodes will take less than a second for the entire cluster to know that these 3 are the dynamic control plane. This will proxy straight to one of the control plane nodes. So it's not just going to keep asking randomly. This was when we were building the control plane. It will have to ask. When it is actually having a control plane to run, this will just proxy you straight to the control plane because this node will know these are the control plane for that data plane. One second, let me make what you guys are saying big. All right, YouTube needs to be bigger. There we go. Now we can read it. Why not use mesh for asking the node? I'm not sure I understand what you're asking. I need to think about what you're asking there. Okay, so question is, how do you extend the functionality to handle additional resource types, which is something Kubernetes control planes handles, like integrating Nginx as a Kubernetes resource with rules? Because this will be handled by this control plane, your data plane control plane. This will act as the control plane for whatever you deployed to these. Right? So you should be able to handle any of those things here. You're not going to have one of these for the whole cluster because Kubernetes sits here and tells everything what to run, where and when. But you don't even ask this when you're going to this. You make a service. I have a video on where are my services with Kubernetes services. Kubernetes services work this way. This is how a Kubernetes service works. You ask any node, and any node knows where that thing is running. So a Kubernetes service already works in this way. So I wouldn't actually be anything different than a Kubernetes service here, actually. Go watch that video after the stream. Unless I'm misunderstanding what you're saying, Grampington, which is possible. I could be completely misunderstanding. Oh, you mean the custom resource definitions? How do you build custom resource definitions? So that's actually what we're doing here, where this is a Kubernetes operator. Okay. So custom resource definitions. That's a good question. I think that it will actually be easier to add new resource types. But my question is, what do you do? Why do you use custom resource definitions? And you could say that a custom resource definition allows you to add a new type to Kubernetes, but I would actually contend that's not why you use it. I would contend that the reason you use it is that it provides an easy operator. What do we need out of an operator? We need, what do you need for an operator? I'm contending that you don't extend the Kubernetes API because extending the Kubernetes API is what you want. What you want is you want an easy operator. And if you have Kubernetes, this allows you to do it. You need consistency. You need a consistent data store that's highly available. So high available, consistent data store, so that you can have multiple operators working off of the same data. You need to be able to do that. So what does Kubernetes offer? Kubernetes has a, you know what? I need to put this on the side here. I need to make it not purple because that's hard to read. All right. K8s provides etcd, which provides all of this with Raft. Okay, so you have that. And then the other thing that you want to do maybe with one of these is you want to leverage the Kubernetes scheduler. So you basically want to be able to ask the scheduler to do stuff. Yes, Grumpington. etcd 100% uses Raft. Sorry, I didn't make that clear. That's the protocol it uses. This is why I was saying it's a chatty protocol, and I was demonstrating how chatty it is. Because it is chatty and it will give you network congestion problems. That's actually why when I talked about it here, I was telling you not to do this many Raft nodes because it gets very chatty very quickly. Yep. So etcd uses Raft. Anyways, you want to leverage the Kubernetes scheduler, and you might want to leverage other K8s things. So you might want to make deployments. You might want to, let's see, we'll just say deployments, pods, other CRDs, etc. Now, a CRD is a declarative method of defining one of these things, which is good. This should be declarative too. I like declarative because it allows you to do infrastructure or whatever else as code, which is good, and I like it. Or Git operations, GitOps. And this is actually a really good point, Grumpington, that you're making, that you might want to do those things. Did you know that a deployment is just a operator at its core? It's just a built-in operator. Deployments, replica sets. Pods. These are just, networks. We can go on with the built-in, your stateful sets. All of these things are just built-in CRDs. They're not C, they're just resource definitions. The C is when you're custom resource definitions. But these are just RDs. These are RDs. And so yes, is this a central control plane that provides this ability, or is this something else? I would contend that we can provide this type of thing without the central control plane. I don't think that you have to have a central control plane to provide a way of having these types of known things. Now, exactly how we do this, you're right, would have to change, because this is defined in your control plane. Now, we could say that we have to distribute out all of these things, but we can do it in the same way that we do this. Let's say you install a new custom resource on this. We're going to give it pink. And it's going to find a couple other people to be managers with it. I don't know. I'm not going to design this right now. This should support this. I have some ideas for how you can make these types of things where you can extend it. I actually would also contend that when we make a deployment replica set, pod, or stateful set, that we make them custom resource definitions, not built-in. I don't like how Kubernetes has the built-in, because this lets more community involvement, as well as a way for people to change how deployments work. Because instead of needing to edit on Legion itself, you edit on the repo for the deployment one. And that means that it's a smaller code base that's only focused on doing the thing. It also means that you have an example of how to make a really awesome custom resource definition. This is something that we should design, but I don't think that we need a central control plane to handle. Correct. You are correct in how Kubernetes does it. 100%. And that's what we're leveraging here. You are correct. That is, I mean, the Kubernetes leverages the control plane all over the place. It uses it to schedule your application. It uses it to provide a API. It uses it to configure all of the nodes and handle all of that stuff. So when you make a new deployment and the pods run here and here, the control plane is the thing that forces all of these to update its networking so that you can, the service is. So when you make a service, that goes to the control plane, and then the control plane says, hey guys, this is the service for this deployment over here. I'm just removing the centralized ability of the control plane. We shouldn't lose any functionality of it. But you are right. That is 100%. It's a little, I guess it is a little misleading if I say all it is a scheduler. It's not just a scheduler. The main thing it does is a scheduler, but it also allows people to leverage etcd. That's kind of its second thing, is it kind of publicly exposes at a unified API etcd. And then like the tooling, like Kube Builder, leverages that to give you updates when things. But I think we could actually build that in. Like, to me, operators were kind of grafted onto the side of Kubernetes. Let's design that as an actual thing. Because like I said, I would like to see these types of things that Eddington will support be using that. So operators will be a first-class citizen. That's what it should be. An operator should be a first-class citizen in Legion. And basically the operator will be this dynamic control plane is effectively what you'll get, which will be pretty cool. I think it will be. Oh, we're getting an ad break. Oh no. Agreed. We should have one of these APIs. We should. All right, so we're in the ad break. Let's refocus. Let's take this time to refocus. I'm going to go get a drink since we're in an ad break. I'm getting a drink. I'll be right back. Thanks everybody for watching. We'll be right back. Grampington, you're too cool for ads. All right, well, I'm still going to get up and get a drink. Everybody else should get up and stand up a little bit. Get a drink. All right. Oh, ads are still in progress. Perfect. Welcome, Grampington, from both. Nice. Yeah, Grimpington, you're absolutely right. It should absolutely do these things. And that shouldn't be a blocker. Obviously, I haven't made this, so I say it shouldn't be a blocker. Do I have every detail down? No, I don't. No, I don't. So there's definitely chances that, stuff will have to change around a little bit, but yeah. I have designed a few distributed systems in my life, so I'm fairly confident with what I'm doing. But There's definitely some open-ended questions. All right, so here we go. The other thing that we have here, and I'm going to move all of this stuff up here, over here. So these are the things that run directly on Kubernetes. These are the operators here. So let's redo this over here. Type kube operator. So we do have these two operators that run directly on Kubernetes that do these things. And then we have this API that sits here. This is our monolith. We're system designing here. Then we actually have another thing that sits, you know what, this is actually going to be a square. But we do have something that sits here in front of everything. And this is ingress. And we actually are using this is Istio. Now, the reason we're using ingress is this, because a lot of times I would tell you that if you're using a service mesh, you've maybe messed up, unless if you're really massive. But what happens is that I have to expose the things that are running. So we'll put users apps just to be a placeholder up here. Users apps. And these have to be exposed at their own custom route, right? So these things here need to be exposed via a custom URL. And that's what ingress is going to, and it has to be dynamic. It has to be dynamic, dynamic URL. So we kind of have to be using Istio. For better, for worse, for terrible, we don't really get a choice. This is where I was saying Eddington's goal makes it complicated. Now, the other thing that we have to do, and it's being handled here, is we're using Ori. This is actually outside of our stuff right now. Now, what I have come to hate about our design, what I have come to hate, CrowdsWar, you don't even know the basics of about Kates? Don't worry about it. Basics of Kubernetes is it's a container scheduler, or a pod scheduler, actually. It's a pod scheduler, which is a glorified container scheduler. So it just schedules stuff on machines. That's all it does. It doesn't manage the machines. It doesn't manage the things. Grumpington, I have never used those. Istio has APIs to help you dynamically build the upstream cluster. Well, I have never used those, but we are using Istio here. Now, the thing that I don't like, the thing about all of this that I don't love right now, this is actually pretty much it. This is the whole architecture. Istio ingress does this, and then the API calls these things. So when it wants a container built, it calls the container builder, and it then calls this to tell it to start running stuff on Kubernetes. This doesn't know about Kubernetes or anything itself. The only problem here is that all of this stuff has to be multi-tenant. Has to be multi-tenant, which means everything has to have a check for users. So if you go over here, let's go into API. And we were doing some of this. Let's do middleware. There's like this dumb auths that we, auth-z, authorization, where basically we said if it is going to a route that's not yours, then you can't do it, and we'll return an error. And then there's this Ori middleware. And basically what this does is it checks your authorization. And if you're not signed in, so this is put on any route that requires authentication. And if you're not authenticated, it sends a redirect request back to log in. So like all of this stuff is to handle users, but maybe not everybody cares. Well, no, everybody will care about users. You don't. So for me, as an open source project here, I want people to stand this up and be able to use it and leverage it. And everybody will care about users. But the fact is, this part is outside of the thing. And so Ori is an open source project, and I could run it inside here, but this drastically increases the amount of stuff because Ori isn't one thing. Ori is there's Ori Hydra. There's Ori something else that I can't remember off the top of my head. Keros, Keto, Hydra, Oathkeeper. So basically you need these 4 things. So how do I make this simpler? I wanted to make this architecture simpler today. That's what I wanted to do. I'm running out of time. We have 15 minutes, and then we're going to do a few little things on interviews for system design. So Ori could go here or here, but I don't even know that this, let's say we put Ori in here. So we could actually stand this all up with our setup scripts. But now we have got to configure all of Ori as well. And we have to configure it when we're running locally versus when we're running in the not locally, right? For production, because Ori's URLs matter for cross-site scripting and everything, right? Does this solve the issue running inside of our cluster? This hurts my head. I don't know where I've gone wrong. And then this is to be replaced by Legion. Endpoint XDS stands for Endpoint Discovery, which is to request config updates from an external service, which can gather the information based on whatever custom logic. I'm not sure what you're asking to do there with Istio. I probably am just missing it. You're probably thinking of something cool that would fix what I'm wanting to do. But yeah, this is the system. This is the system. We actually also, there's a little thing over here that I didn't point out. This right here, this null watcher. And basically this just watches for updates. Maybe I should put it in here. It's also an operator. Basically, we use KPack to build the images, and KPack doesn't tell us when it builds a new image. And so I have to watch that resource. It's a really dumb little application. It's stupid simple. But it's forced by KPack, which also runs on this. So let me show you my problem. To get this running, if somebody else wanted to run Eddington, this is what we have to do. Let me show you. And then we're going to move on to the interviewing section. First, you're going to want to open up Zellige or Tmux or just a bunch of tabs on your favorite terminal. Then you're going to want to source your Ori stuff. So then you can do Ori tunnel. Then we're going to want to open up a new tab where we can CD into the UI, where you also need to source your Ori information. Okay. I didn't need to do that. npm run dev. Now we can open up a new tab and cd out of here into the root directory and do tilt up, where you can see your things that are running. So once this is up, your backend is up and running. And then you can open up a new tab. Do you guys start to see where I feel like I've got something wrong? There's got to be a better way. At this point, you can start using Eddington. At this point, these are now up and running, and you can run. Now, and Ori is annoying me with this, is Ori uses a session, which maybe is better. Ori doesn't use a JWT by default. It uses a session, which is fine. It actually has some benefits. I don't know why that did that. Which actually has some benefits. But one thing that actually I just found out recently that really annoys me, or we need to figure out, is this. I don't know how to use it in Postman. I can't actually send an authenticated request in Postman because I don't know how to send the session information with it. So then to debug this, what we have to do is we have to go over here and jump into main and uncomment out. Let's see, where is it? Debug this stuff. And now we can run it without our Ori middleware. Now, I have a solution for this. I don't think it reduces complexity. And that's remove authentication from the authentication, not authorization, authentication from the API, the monolith, and do it instead here. Terminate. Yeah. Because all this needs to do is put all this needs to do what the Ori middleware does and our debug middleware does, is puts the user ID in the context. So maybe this is the way to do it. Maybe the way to do it is this. Have we decreased complexity? Because if this happened, then all of these middlewares go away. All of these middlewares go away. Right? We don't care about the middleware. How or what Istio does is Istio's thing. And if we just don't do auth in Istio and we just pass a user ID through to the app, that will be good for it. It won't care, right? Or if we configure it with terminating this. Now, I know how to do this with a JWT. I don't know how to do it with a session, though. I can do this with a JWT. I don't know how to do it with a freaking session because Ori uses sessions. I was going to show you here. You can actually see the session token here. If you go in here and go to storage, instead of in your cookies, you're going to go to local storage and you're going to see your session. It's a different way of dealing with authentication than a JWT. It has its pluses and minuses. It is super fast to one problem with JWTs that I would expect a system design person to know is that they take a while to invalidate. They take a little while to invalidate, or can. I know. Okay, so you know what I'm going to do? You know what I'm going to do? We're going to go down this path here. And I'm going to see if I can't make Oreo. I keep saying Oreo. Ori, send me a JWT. I believe they have documentation on it. I think you can force it to do that. By default, Ori issues opaque access token, which are random strings with a cryptographic signature that have no meaning or structure. Opaque tokens are so anyways, yes. I think I can force this to be a JWT. I might also be able to just handle a session session in Istio. So I'm going to research that, and maybe we'll do that next Saturday. Maybe that will be what we do, whether we are making it use a JWT and just doing that in Istio, which is the thing I know can be done and have done before. Because I would like to get away from deving with this. This is a terrible dev experience. I would love for people to be able to use this without... And then, you know what this also does? Is it lets people bring their own authentication if they don't want to use Ori. If they want to use Auth0, use Auth0. Because it's not built into the app that I have the Ori API. Or, you know, because right now, all of these things are leveraging the Ori APIs. Okay, we're going to go down this path. Thanks for letting me think that through with you all. I know that we just spent an hour going all the way from Legion to whatnot, but I wanted to do this. Awesome. Okay. Because I wanted to write the code for this stuff, but I needed to rethink it. I needed to rethink it because right now what we have is kind of disastrous. Or not disastrous, but... Yeah. I use Twitch and YouTube as a duck. You are correct. No, you guys actually are helpful. You guys are, you know what you're talking about. You know what you're talking about. Okay. So, what are we doing right now? Right now, we're going to jump over to system design. Now, I know people have been asking for this, so we're going to do a few of these types of things. I'm also going to mark these. I just hired a editor, my daughter, but hey, a dollar per one of these. She's gonna make not shorts, but she's gonna clip them out for some of these things that we do, so that there's gonna be like these segments out as just standalone videos on some YouTube channel. I don't know, probably not the live YouTube channel. I might have to have a third YouTube channel. That sounds gross, but we'll figure that out. She's gonna cut them for me. I'm gonna show her how to do that, and that way, some of these times when we actually go over something, we can have it cut out from the big long live stream for either future review or for people that just want those, you know, tidy little sections. All right. So I think I can actually do this here. I think I can do this here. Something like a marker. Yeah. All right. We'll see if that works. We'll see if that works. It might have to be like another YouTube channel. I'll let you guys know exactly what we're going to do. We're going to get a couple in the pipeline this week. She's going to learn. And, you know, it shouldn't take her long to make any one of them. But then it also means I don't have to do it. And she can just do it. She's excited about it. I'm excited about it. Hopefully you guys like it. Let me know. It's going to be expensive. $1 per video. We'll see how much work it is for her. If it's a lot of work, it shouldn't be. I did one just as a test. It should be like 10 minutes. But we'll see. Okay. So let's do system design. Welcome. If you're just joining, we're going to cover some system design stuff. And in the comments, if you're watching this video not live, I recommend you, if you have questions about a certain system design or interview question, go ahead and ask it. We'll be covering these throughout the year, and today we're going to pick up a Design X question. Next week, I think we'll be doing some more around a CDN, but today we're going to do Design X questions. Design X, I'm not talking about the social media app, although we will be doing a social media app. What I am talking about is design a cache, design a CDN, design a delivery app, whatnot. And I have some basic recommendations for those of you that are going to go over that. I kind of wrote it as a blog post, but it's not a blog post. You can't find it anywhere. But if people would like me to write it up as a blog post, I can. But we're going to go walk through this. This is my basic recommendations for a design of X or design of Y interview. And then we're going to jump in and do it for a social media app. Now, if you guys would like to see me get interviewed, I can do that as well. I'm super dumb when getting interviewed. I forget most of everything that I know, but I'm happy to do that. So if we want to do that, we can do that at some time. I'll get Russell or Dirk or some of the more experienced people to interview me. And then we can go through and pick apart the interview, what I did bad, what I did well, and things like that. Okay, so basics of a Design Y interview. I changed it to Y. It used to be X but then I thought people would get confused that I was asking them to design X. So we're basics of a Design Y interview. Thanks, Elon, for ruining that for me. Thank you. My goodness. I didn't realize it was going to cause me problems. All right. Do I freelance or do I work somewhere? I work somewhere. Believe it or not, I pass an interview. I don't know. Every single time I pass interviews, I'm like, the stars aligned. The stars aligned. All right. So most design why interview questions are open-ended on purpose. Okay. So they're open-ended on purpose because anytime you're doing system designs, one of your goals, maybe one of your biggest things, is to gather requirements. Like as an engineer, if you're asked to design a system, you have to know what that system is. You can't just say, oh, we're going to use microsystems and we're going to do this and this. It doesn't matter. It's all crap if you don't know what the system is. So I leave these system design interview questions really open-ended. I might say, hey, so let's design a social media app, without even telling you what style of social media. Is it a messaging? Is it a whatnot? That's super open-ended. And what I'm looking for is somebody to not say anything but a question. Like the first thing should be questions. Now, I don't leave it so open-ended for newer people because I don't want to be cruel. So a lot of times if it's like a junior engineer, somebody fresh out of college, I'm going to say, let's design a social media app like X. So I give them, some place to start. And a lot of the times if they're fresh out of college, they just go designing X without any questions. Ask questions. You need to ask questions because if I say like X, I don't mean just X. I mean like similar to it. So ask questions. Yeah, one of the biggest parts of system design that you'll have to learn is learning to figure out the requirements. The first part of this test is to test to see if you understand that. That's 100% what I'm looking for. So you want to ask generic questions. This is one that I love to see. Ask really broad generic questions and then use those to drill down further in. Okay, you said this. Now what about this? So this shows that you're asking purposeful questions. You're trying to understand how much throughput. So you're going to ask, is there a time of day that the app is expected to be used more? How many users? What type of messages are going to be sent? Is it a messaging app? Or is it posts, microblogging? Or is it pictures? Because these have effects on your storage. And you can then, as you learn more, you can ask questions to follow up on that. That it's really good if you ask questions that you can follow up with. But yeah, start with some generic questions. It's good. Don't feel like you have to ask all the questions up front. You should start with questions. But you don't have to cover everything. I don't expect you to sit there for 3 hours asking for requirement. It is an interview. We have an hour. Ask the basics and then start moving into it. Now, this is where I would say, like, the more experience you have, the more thoughtful questions I would ask you to come up with. I gave an example here, but like a junior engineer might ask something like, how many daily active users do you expect? Whereas a step up from that would be like asking for usage patterns, and an even further step would be like the expected types of activities. As you drill down, this shows more experience, whereas like a newer engineer is going to be like, oh, daily active users is going to tell me, what my load is. And then what you really realize is like, well, yes, but you got to design for the peak. And so then you really need to know the usage patterns and then to design for the peak. And then, you really need to know what the type of expected activity is. So yeah, I also put this note in here. Please don't try to calculate the exact size of a payload. I had somebody spend 20 minutes trying to calculate the exact size of a payload. And it was like, dude, you make an estimate. That's fine. You say, hey, we can estimate that, let's say we upload pictures and this is an Instagram-like one. We're going to cap it at 5 megabytes per picture or 1 megabyte or whatever it is. And that's going to be the cap. And we're going to compress the images to that, period. Okay. Make assumptions or as long as you verbalize them. Like, don't assume things, but you can make assumptions. Like, I'm going to assume that, or how I like it when people make assumptions is to make it in a question. Can I assume that the growth will be steady? Or can I assume that it's okay to compress these files to less than 1 megabyte or 5 megabytes? Or you can say it as an assumption like that, or you can say it as like, is there a maximum file size that we're going to support? Can we compress them, and those types of things like that? So it's okay for you to make it as like an assumption in my book. Now, when you say this, you'll get an idea if your interviewer is okay with that. If you say, can I assume that the growth will be steady? If they don't like you making any type of assumption like that and saying it in that way, the first time you'll know. Remember, you're also interviewing that type, the person across from you. And it's okay to read how they like these types of statements. Would it be okay if we said Android is out of scope? All right. Absolutely, Grumpington. Can't know the requirements in advance, and it's not like exact size matters. Another thing about the exact size payload, this is always going to change. I like whatever you exactly calculate with, the max size of the name field and whatnot. It's gonna, like, there are so many PMs that are going to screw with your exact size of that payload. You are fighting a losing battle. You have never met a PM, okay? You have never met a PM. That exact size is going to get screwed. Number one. Grimpington, that's an excellent point. What do you mean expected type of activity? Chad, man, I will get to your answers in just a little bit after this. Is it peak viewing posts, videos, or does peak involve creating a lot of comments? And what you mean by expected type of activity is like on Twitter, there's a lot of stuff that you can do. What is it that you expect people to do? It's you expect at this point to tweet or to zeet. I think it's zeet. It's either zeet or skeet. I like skeet better. Actually, skeet. It's skeeting. That's what we're going to call it. So it's expected that you're skeeting. But maybe that changes. But in general, that's what you're trying to understand. When you hit peak, what does that look like? And this is why, again, when I'm doing the system design interview, I'm looking for different things from different experience levels. Because a lot of the times the question's the same thing. The question doesn't change whether you're a junior engineer or a principal engineer. I'll ask the same question. What does change is my expectations of what you ask for. Again, a junior engineer maybe just stops at how many daily active users, doesn't even know usage patterns, doesn't even know the expected types of activity. And that's okay. That's okay. It means that they're thinking about it. And that's good enough for somebody fresh out of college. They thought, wow, what type of load am I going to have to deal with? And they'll learn the other stuff. Somebody with a couple years, I'd expect usage patterns. If you come to me with more than 6 years, you probably should be expecting the types of activities because you've been burned by this and it's hurt. So yeah. At this point, this is kind of the first segment. Ask a bunch of questions. Then you're going to move on to an initial design. Now, I'm going to say, keep your initial design simple and clean. Keep it simple and clean. There's going to be time to go into more detail, but the thing that you want to do with your initial design is to prove very easily at a high level that you understand the complications of and answers and requirements and how to. That sentence came out really poorly. I'm sorry. So what you want to do really simply is prove that you can design a system to fit for the requirements that you asked. So I'm going to expect that you incorporate all the questions that you asked. That's you're designing a system, and I change it up. Like, there's no specific system I have in mind when asking this. There's no specific one. What I'm going to do is I'm going to hold you ask a question. I'm taking notes of the questions and answers you've gotten, and I want to make sure that you design a system that fits what we agreed upon. Okay? So you want to keep a simple design here. Keep it clean. I always like to draw here. I love it when people draw because it's easy to understand. When people are like, oh no, we'll just speak about this. It's hard to keep it straight. It's hard. So it's really nice to just draw it out. Ask for something to draw with. I think it will make your life easier. And expect us to ask questions. Expect you to be drawing something out and us to ask questions. Now, don't consider a question to mean that I don't like it. Because this is what a lot of people will do. They'll be like, hey, we're going to use a monolith. And I'll be like, why are you using a monolith? And then all of a sudden they'll be like, oh, well, we could use microservices. No, don't. My question is because I want to see that you had a purpose behind your pick. Whether I agree with the purpose, honestly, doesn't even matter to me. If you can sit there and defend it reasonably with assumptions based off of the things that we talked about above, that's all that I'm looking for. Did you make a decision based off of what we talked about, or are you making a decision based off of what you think the industry happens? Now, I'll tell you what happens a lot of times. Everybody here will say, well, we'll use microservices. And then I'll say, why are you using microservices? Because they haven't asked the number of engineers in the team how we're going to do team structure or how the company organizes their work. And if you haven't asked those questions, how the crap do you know how we want to organize our microservices? If you're just saying in architecture because you think it's in, that won't fly by me. I'll give junior engineers that just graduated college a pass on this one. Everyone else, it's a hard fail. If you said we'll use microservices and you didn't ask anything that relates to using microservices, it's a hard pass from me. Maybe that sounds a little my point here, though, you can't design something you didn't ask about. So if you didn't ask about it up here, don't design for it. And if you're saying, oh, well, we could use microservices, you could catch yourself. You could be like, well, except I guess that brings me to how do we organize? Because if we're going to use microservices, I think that means that we need to have a team structure like this and probably be a larger company. So I guess maybe, something I didn't ask above would be how many people are going to be working on this? How many engineers do we have? Start asking them. It's never too late to ask questions. So if you get to a point like this, go ahead and ask questions. You're not stuck with the initial questions that you ask. Again, you ask a certain number of questions and then you move on to the initial design. But make sure that if you're designing it, you have made those designs based off of stuff that you've asked questions about. Don't design from popularity. I hate people that design by popular things because you should engineer your app. You're an engineer. That's what you're getting a job for, right? So yeah, pro tip, I love it when people ask about the company, this fictitious company, that we're building this app for. Absolutely love it because it means they understand the bigger problem. They're designing something not only to handle the front end use case, but they're handling it for the people that we have. If you said build it in Java, I'd be like, do we have Java engineers? I don't know. Hopefully the answer is no. All right, never design a system without knowing the tools at your disposal. So, all right. Okay, so after you have a big high-level design, this is the part where I want you to show me what you're best at. I really want you to dig into, some of the details. Don't go too far, but start to expand on the details, okay? I don't expect you to know everything about a system design. The systems can be large, can be super complicated. Show me what you're the best at. Now, I'm going to warn you though. I said show me what you're the best at. Expect me to know that if you're skirting around something, that you're weak at that. Don't expect me to be an idiot, okay? And don't expect me not to ask questions about what you're weak at, okay? It's fine to say I'm not as good at that. Be open and clear to me because I will know if you're weaker at it. Just be like, I'm weaker at it, and then explain the best that you can on that topic. So if I ask you about caching and how you're going to leverage caching and you've never done a whole lot of caching, that's fine. Be like, well, I don't know caching very well. And we'll get into this when we actually do one of these. But here's some of the reasons you could cache and some of the places that you could cache. And in general, at a high level, this is what caching does for us. There you go. You solved it. But be prepared to at least defend at the very highest level what that thing is. Also, if you say that you have 5 years of experience, I'm a generalist. I've always been a generalist. I probably always will be a generalist. If you say you have 5 years of experience, I am going to expect you to be an expert in something and know more than me in something. So I guess maybe that's not fair, but that is kind of how I go about it. I'm going to expect you to know more than me in something, unless if all of our expertise line up, but that's generally not true. So I'm going to want to see you explain some system really, really well, some part of it really, really well, whether that's the security part of it, or whether that's the scheduling part of it, or if that's the whatever part, the caching part of it, whatever part, explain it well. All right, I know that more than you in tons. Perfect. You only know more than me in anything mobile. So I guess there's tons there. Fair. All right, and then what you want to do is wrap that up. You're just going to want to take that, talk about how that whole system, what you need to make sure in this, after you've done a little bit more detailed design, you want to make sure that all of that goes back to what we discussed as the system design. So when you're done with that system design, make sure that you can defend that it meets the expectations and the requirements. That's all. This isn't a real section. This is just something that you should be doing throughout this. Do you much prefer being the interviewer? Me too. So this is my base guide of doing Design Why interviews. Would you guys like to do a social media app? Or was that good enough? Eagle 11, how would you like to be interviewed for a mobile developer live? I'll do it. As a system design. So we'll just talk about the backends that power the mobile apps. I'll let you interview me. You'll nail it. Let's I had a few questions. Let's jump. Do you freelance or do you work for I work for the Sith, effectively. I'm pretty sure that's what you're asking. Yes, I do work for the Sith. If you know me, the answer is I do not work in front end. I work in anything but front end. Anything but front end. Ask anybody. And the answer is anything but front end. Also, no problem. I ignore messages. Never apologize for interrupting because I ignore messages faster than anybody. So no, we were in the middle of something, so I did ignore them for a little bit, but yes. I don't do front end very well. I do it very poorly. I love system design. I love back end. I love not front end. Can I write front end? Absolutely. If it's React, I can do React because I like getting paid. Okay. I can do React because I like getting paid. Just like I can write Java because I like getting paid. You know, we might talk about how much we love Rust. Dude, so honestly, front end is something we're going to do more of. I have this stupid Vue app that we need to make this year, and so we'll be doing some front end. I wanted to learn Vue because everybody says Vue is nicer than React. I kind of thought about doing Solid instead of Vue, or Svelte instead of Vue. I could be convinced not to do Vue and do Solid or Svelte. I could be convinced to learn one of those. React and Next.js are the two things that I could do passively. Can I make a website? Well, probably. Right. Can I make a website? Absolutely. I know all the technologies. Will it look good? No, it won't. Check this out. Does this look good? This looks okay. I didn't actually do this. Does this look good? No, it doesn't. Why is this gray bar up here? I don't know why it's up there. It's up there because it's chilling up there. I don't know why this is gray all the way up here. It's garbage. It's garbage, okay? I desperately need a designer. So yeah, Grumpington, Eagle, I'm about the... Yep, I think we're all back-end engineers here. It's a website regardless. Exactly, Nighthound. Exactly. Exactly. Angular. I want to talk bad about Angular right now. I want to spend a moment to complain about Angular, but I don't know enough to know about Angular. The only thing I know is from people who are good at Angular who complain about Angular. So I have like third person Angular hate. I have third person. You be roasting your whole I can't roast anybody about front end design. I can't. That's like I said, I can third person roast people about their front ends. I don't know. Eagle 11, did you see the first place we worked together? Did you see any of my code from there? You saw some of the Android stuff. That wasn't the worst. That was after I had coded for a little while. You know what we'll have to do? The person who mentored me. Oh, you shut up, Eagle. The person who mentored me, I'm going to have to get those two people online. They saw some real trash code from me. Mac and Travis, I need to get them online because those two people put up with my initial code. Mac and Travis, these people are effectively saints. Mac is not, but Travis is. Mac and Travis taught me 3/4 of what I know. Those poor people. Okay. So you know what? I want to be upset with what Eagle is saying, but knowing what I know now and understanding them, he is He is not, and Mac would agree with my statement. That was not rude to Mac. Mac is a fantastic person. Fantastic person, not a saint. I like Mac. Mac and Travis put up with some of the like I'm a self-taught software engineer, and at that point I was like the worst of all self-taught software engineers. I thought that I was good without really knowing anything about real software except what I taught myself. And they not only put up with me, but they worked to form me into something a little more humble and a little bit better, quite a bit better. Eagle knows what I mean about with Mac. I wasn't being rude to Mac. Mac is a fantastic person, not a saint. Very honest statement. Fantastic person. But being honest, they put up with me. I would love to get the two of them on stream to talk about it because I think that they could tell you stories that would be hilarious. I think they could tell you stories. I'm going to message both of them and see if they would. I don't think Travis would, but maybe we could get Mac to talk about first years of working with me. Would 100% work with Mac again. Great person. I think he could tell you some stories, and I think it would be hilarious. I could get, there's a guy named Daniel. I could get him online too. See if, some good news. Dan Lornick is going to join the stream again. Going to get him on to talk about Chain Guard specifically. I felt bad because I didn't actually ask him about Chain Guard the last time I had him on. And so, yes. Gonna talk specifically about Chain Guard, what they're trying to do, what their future plans are. Gonna be exciting. So stay tuned for that. I have another collab with Dan Lornick, hopefully that we're gonna do as well in the future, which should be pretty exciting. But yeah, those two people, great people. I'm gonna try to get them on stream to talk about the terribleness that I came from. And I do that because I want to encourage people like, you don't know everything right now. I still don't know everything. A lot more than Eagle 11, but I don't know everything. And the thing is, we all come from certain places, and that's what we're trying to do here. We're trying to level up our game. We're trying to get better. We're trying to learn. Okay, let's get back to it. I don't know anything. I'm pretty sure I'm with you. I don't know anything. I just interview people. Interviewing them is way better. Way better than being the interviewee. Way better. Dude, seriously, I get into an interview, literally forget 3/4 of everything that I know. I'm in there trying to remember my children's names. They're like, oh, you have kids, what their names? And I'm like, don't ask me such hard questions. I call them 1, 2, and 3 most of the time. Forget their name. Yeah, I one index my children. I don't go 0, 1, 2. Huh. I'm a terrible person. I one index something. It starts with 0. All right. All right. Yeah, I blew it my children. Oh. The thing is, I have written some of the worst code. One of the worst things that I've ever done that Mac can attest to is he is the one that put up with the 13,000 line file. 13,000 lines. That's what Mac put up with. All right, so let's step through all of the steps that we did with the basics of a design interview. So here we're going to actually take this and actually implement it. I'm just going to walk through it. If you guys would like to see these done as more of an interviewee style thing where there's actually an interviewer that's going to ask me questions. You get somebody like Russell Grempington or whatnot to come on the stream and interview me, I will 100% do it, and we'll do that the next time. The only thing I want to do is make sure the person themselves knows the topic well enough. You don't have to be an expert on it to interview, because a lot of your job as the interviewee or the interviewer is to ask questions and force them to explain why they're going to design something the way that they're going to. Okay, so let's jump in and design a social media app as an interview. So we're going to do this. We're going to actually make it its own folder because we're going to do some drawings along with it. So design a social. All right, so now we can put in our, you know what? If this is a light background, I'm going to be upset. Oh, I'm sorry. My goodness. That is... Oh, we have an ad. Let's just do this. Ads. I'm sorry. I'm going to go get some water. Be right back. All right. We're back. Maybe. Are we back? Ads. Oh, ads 14 seconds. 14 seconds. 10 seconds. All right. Let's see. Let's add another marker here. So for those of you guys that don't know, if you're not from Europe or America, most of the time you don't get ads. Most of the time they don't have they show regionalized ads, right? And so if they don't have an ad for the region, then you don't get an ad. So I should have done another marker for when we were done with the other thing. That's a note for me to remember. When we finish one thing, put a marker. That will make it easier to cut. Yeah. All right. Let's jump into it. All right. We're going to design Twitter. I'm going to actually just make this Twitter. So, actually, the first thing that I would ask, what type of social media app? SMA. There's SMAs. What type of social media app? That's going to be my first question. So we're going to design, nope, undo that. We're going to design Twitter. Easy. Okay. Cool. That narrows stuff down. I'm going to ask a few follow-up questions on that. Like, wow, I screwed stuff in there we go. Okay. Do I need to support video? I'm going to say no. Okay, cool. But that would be a follow-up question I would have immediately was, I know Twitter has just gotten into it, but whatnot. Then I probably would say something like, can I assume the same requirements around tweet length and the ability to follow others? You know, I'm making an assumption, but I'm making a statement. They could say that they have a different requirement, and that's fine. But this is edible tweets is pretty good. You can't eat any of these, but we might be able to edit them. And I'm going to say yes to this. That's a good follow-up on, can users edit tweets? I'm going to say no. You know, we're going to say yes. We're going to say yes. We're going to talk about it. We're going to talk about it. Yeah, we'll talk about that. Now, when you design Twitter, when you're asked for these things, there are specific things. You should know the specific challenges to some of these big platforms. Whether you ever need to use them in real life doesn't matter. You need to know them. It's like with designing Google Docs. You need to know that thing that lets you both edit the same text at the same time. There's this very specific thing that enables that, and we'll get into that, but you need to know it. And there's a very specific thing with X that they solved that you need to know. It's just, if you're designing Twitter, you need to know that. They have something special. Now, it doesn't mean that you need to do it, because let's do this. How many expected users? We're going to say 500,000. Follow-up question would be expected growth. Which we're going to respond with none. We're just designing a system for 500. We'll say 50K a month. Just something. Then we're going to ask some follow-up questions about the time of day. So what is the time of day? Expected usage patterns. So So we're going to say evenings. I don't know if that's actually Twitter's. It doesn't matter. It doesn't have to match Twitter. We could say mornings for all we care. Heavy mornings, medium evenings. Again, I don't know that this is true. It doesn't matter. Okay. We just know that we're going to have two peaks, a little peak and a big peak. It's probably flip-flopped, would be my guess. I don't know. All right. And then the types of traffic here. Well, a really good follow-up question to expected usage patterns is what they're going to do. So we could say something like expected and expected traffic types, in the mornings, it's going to be tweets. And in the evenings, pictures of food. We don't accept anything else, just pictures of food. That's all you can upload. That's actually a really good one. So, Trouter, the expected time zone, to me, it should be localized. But is also a good one to take into consideration. We do need to enforce uploading pictures of... You guys knew I had to work AI into this, right? How else do you think we're getting AI into the Twitter? Pictures of food only. But very specifically, not being funny, this is important because uploading pictures is very different than tweets. The part of the system that handles this versus this could be very different. So you have to understand that for scaling. This is actually not arbitrary as far as system design goes. It's a good... I meant it as a, sure, maybe the of food part. But pictures versus tweets can be important. And we'll do... expected time zone. Okay. For right now, we're just going to design this in the US. It's easy. Again, a lot of the times the interviewer is not going to make it overly complicated. They don't want to see overly complicated because there's just not enough time to get into overly complicated things. Not enough time. All right, this is easy enough. We can start here. We don't really need to know more. So I'm going to go ahead and start designing here. And then I'm going to ask some follow-up questions. Actually, one that I usually ask before getting into it, although some people do, is what is our company size? And how many engineers are going to be working on this? I find this to be really important. So ask this. Because you know what? Ours is going to be a 5-person company, 5-engineer team. That's it. We have 5 people working on this. In a system design interview, I do not expect people to care about the language. This is a very real question, and I wouldn't be upset if people asked. But when we get to actually drawing it out, I wouldn't expect them to be like, service A Java. They're just going to talk service A. That's what they're going to do. But it is a good distinction, though. It is a good distinction. Okay, so let's pull up a whiteboard and talk about this a little. Eagle 11, you wouldn't expect the what company size? I would from somebody designing a system. Now, you're right, a junior engineer, probably not. I wouldn't, but anybody designing the system, what tools do you have available to design? If you're designing a system without knowing the tool, like, this actually really changes. If you said that I had a 500 engineer team, this changes. And the reason it changes is that you can't have 500 engineers work on a monolith. Probably. Not sanely. You can have 5 engineers work on a monolith sanely. A lot of people have worked at a company of one size. Sure, agreed. Yes. Only worked at a company. Agreed. A lot of companies haven't worked at Twitter, but I would still expect them to understand what the fan out and fan in is that they had to solve. Even though I haven't ever actually had to deal with that problem myself. I haven't had to deal with the Twitter problem, but I still understand it at a high level. I don't know it intimately. I do know it at a high level. And I would expect somebody going through a system design again, this is me going through it. I'm telling you the questions I would ask. I already talked about that in the basics, that there's different levels that we would expect, 100%. This is just me going through an example for you all. So one of the things I would ask, and maybe I'm more on that principal or management side, is how many engineers are going to work on this, because I think it matters a lot. So this is what I'm showing you, a little insight into maybe what I would do. I would hope that you do this, because what I find so many people do is they say, so we will use microservices. And I ask them why. And they say, because microservices let us scale. And that just forces me to fail them. And it hurts my heart, because they're smart people. And the thing is, microservices don't let you scale horizontally. Statelessness. If you have a microservice with state in it, it can't scale horizontally any better than anything else can. Statelessness. If you have a monolith that doesn't hold state itself, can scale horizontally just as well as a microservice can. So, I'm just trying to help people not get failed in system design interviews. Now, maybe you could argue that this is me and I'm harsher and I'm harder on system design interviews. Maybe. I don't know. What are your guys' experiences? You know, there's probably people out there that want to know the keywords. They want to know that you're using microservices. And I probably would fail their system design interview, because I'm like, it's not always the right choice. All right, let's keep going. So we have our questions. Let's design this. First thing that we're going to do is we're going to just mock out. We're going to think through a little bit of the system. So we're obviously going to need some databases. I'm going to make databases circles. Databases are going to be circles, and services are going to be squares. Now, since we're doing just 5, we're going to try to do this with as few as services possible. If possible, a monolith. since our requirement was 5. Now, you know what we can maybe do is maybe we can do this again as a larger team. Let's say 25. But for the time being, we're going to try to do it with just 5. All right. So we're going to need a data store for tweets. We're going to need to store data, store tweets. And then we're also going to need, you know what we could do? You know what we could do? This is going to be more fun. We're going to make a database. Oh, that looks so good. Line these up. There we go. We got this. One second. The database is coming to fruition. There we go. There we go. That's better. Tweet database. It's a tweet database. Okay, cool. And we're going to actually need to know one about users. Now, our goal here is that we're supporting 500,000 users. And we know that they're tweets, the 160 characters. Let's put that in there. Tweets, 160 characters, and pictures. So we're also going to need to store pictures somewhere. Databases aren't the best place to store pictures. If we're building this in the cloud, are we building this in the cloud? I'll let you guys answer. Are we building this in the cloud? Grambington, microservices do let you scale more uniquely, and that's a fair point to bring up. Absolutely. It allows you to scale individual things instead of everything. A monolith will require you to duplicate everything. Now, I would be careful with that argument. And the only reason I say that is, let's say this is your code base and it does a bunch of stuff, but it has an API. The code itself doesn't take up very much stuff. And if that code isn't running, you're not really wasting that much time. So there's like 100 API endpoints that you have here. But let's say this is the hot one. There's one hot one. That's the hot one. Scaling this whole thing again, just for the hot one to be called on, doesn't really change anything, does it? Like, sure, if it was a microservice, you could just scale this API. Now, there are cases, if you wanted to start talking about webhooks, or you wanted to start talking about stateful things like this, where the scaling is unique, or message queues, 100%. But talk about those. If you're going to bring those up as a reason you need to have microservices for something like that, because you know that service is, I acquiesce that that's a fair argument. That's a fair argument. You just need to know why. You can't just say because it scales. That's my problem. Too many times, people will say, well, that it enables us to scale horizontally. But yes, there are reasons to break things out like that. And like we discussed with Eddington, we actually have a monolith with a few things that make sense to be broken out. At least I think they make sense to be broken out. Because they deal with Kubernetes and they're not contaminating the rest of them. And that actually is contamination. It keeps the core monolith not needing to import Kubernetes stuff. That's why I have that out. Because the core Kubernetes stuff is terrible. It's a reason. Maybe you could argue it's a good reason or not. I don't know. Okay, so we're going to try to make this really easy. So we also need a data store over here. I'm just going to make this as a circle because it's not going to be a database. We need a data store for pictures. Now, I'm going to ask another question here because this brought up a good question. Are we running in a cloud? Are we running in a cloud? What's the answer? You guys tell me. Is this bare metal or a cloud? Cloud. All right, which cloud? Tell me which cloud. I'll design it for it. AWS? Okay, easy. The null cloud? Well, the null cloud, we wouldn't have to worry about any of this, Grimpington, so we're done. We just wrote the app, and all of the stuff that I'm about to write would be just taken care of for us automatically. But if we're running it in a cloud, one of the things that I'm going to be thinking about here is S3. So we have S3. We're just going to store the images in S3. But a good question here is cost constraints. Do we have cost constraints? Now, S3 is super cheap. There are some in and out traffic things, but we're probably not going to be with a 5-person team. I would argue that we can't find a cheaper solution for the images at this point. That's what would be my argument. If you said we're having a 5-engineer team, we can't do that. Linode. Okay. Why not a database? This is going to be more expensive in a database. S3 is going to be cheap and be fast enough. You could serialize these into a database. You could do like a key value store, something, or a document style database. I think S3 is probably the thing that makes sense here. Make an argument for a database. I wouldn't really care as long as you prove that you thought about it. Make it in a database. Okay. So we're going to do S3 for, let's see, this is photos. Can we compress the photos? This is a question I would ask. Everybody says yes. What is acceptable compression for photos? Eagle. that is a great way of doing it. Have them upload. That's actually a viable. So I actually don't want to take away from this. What Eagle? The cheaper solution is allow them to upload to Imager, and you just keep the link to it. This is a viable solution. People do this with YouTube all the time, where they'll have a website and that they want their own videos on, and they'll embed the YouTube videos. They don't build the whole YouTube system. That's not what they bring. There's educational exercise videos or whatnot. It doesn't matter. Don't know, don't care. But the answer is this can be, you could say, in our system design here, that we use a different system for the images. Imager, whatever, Reddit, whatever it is. That's a viable thing. And if you have huge price constraints, you could say that's the only viable way to do it with the price constraints. That's fine. Now, I usually start with the type of data because that helps me design the other systems. This is, I'm just telling you guys this because that's how I think about it. There are reasons we'll get into why An interviewer might right now ask me why I separated these two things out, and I would need to defend myself. And the reason I would defend myself against these two, why I have two different databases, is user information is very relational databases. It very much makes sense to have in a type of relational database like Postgres. Tweet data, there's generally a lot of it, and I think that it would make sense in some sort of key value store that could be retrieved quickly. That would be my argument and my statement to you for these two databases. Now, you could argue for 500,000 people that it could be stored in the user database itself just fine. And you'd probably be right, and I would probably agree with you. My statement here is we have expected growth of 50,000 users, and this has very low overhead, having a separate databases for the tweet, a different style, and ensures future growth in that database where we won't hit as many issues as quickly. But we can get into the bottlenecks. It's okay to have bottlenecks. It's okay to say that, hey, we won't have this, and we'll just have the user database, and that's a bottleneck. As long as you can say, hey, I see this usage pattern could cause problems, that's fine. That's all you need to know. That's the great part about a system design. There's really no wrong answer as long as you know why you gave your answer. Now, they could sit there and say, okay, well, we don't want that. They could just say, well, we want microservices. Design it as a microservice architecture. Okay, well, fine. I proved to them that I knew why I would use microservices or whatnot, and they're asking me to do something else, and that's fine. I can do it. I can do it. All right. So photos are in S3. We have this. We need some sort of ingress into our things. We're going to just use a simple load balancer in the cloud. So there's application load balancers in AWS. So we're just going to get an AWS application load balancer. Because we know that we're running in AWS, so this is pretty easy. We'll do an AWS application load balancer that will actually run through their WAF. The WAF is the web application firewall, which is going to provide us a certain amount of security over being DDoSed and things like that. So we'll just put our WAF right in here. Now, we could use HTTP gateway, but we're not going to. We're just going to use our, to keep it simple and leverage fewer stuff, we're actually just going to leverage our application through the WAF instead of AWS's gateway service, because that's more designed for microservices. And until we go down that path, we don't really need that. If we did go through microservices, I would probably also use Istio, and I still wouldn't use their HTTP gateway because we don't really need it unless if we were going to leverage something. The HTTP gateway really comes into play if you're using Lambda and things like that. WAF is a web application firewall. I'm sorry. Let me spell this out. Web application firewall. This is how you're going to ban bad actors. If there's an IP address that's abusing your service, it's going to do certain heuristics on it and protect your application. Yep. If they're DDoSing, they'll spread the stuff out and try to block the DDoS requests specifically. There's a bunch of stuff a WAF can do, and not all WAFs are the same, but pretty much every cloud has a WAF. A WAF doesn't come natively. You have to enable this. You have to actually put it in your infrastructure as code. Okay, so as we're trying to keep this simple, I'm just going to have a single app, that API app. And this app is going to basically be the thing that drives the web UI. We're going to have we're going to leverage the CDN, AWS CDN. Does it have a specific name? No, it doesn't have a specific name. So AWS CDN, their content delivery network for the front end. That's going to I'm just going to stick that right here. I'm going to stick that right here. We're getting too tall. We're getting too tall. We're just going to stick it out to the side. All right. This is going to deliver our static content when people ask for it, so that mostly the front end. And then we're going to have this API that's going to leverage these things. Now, generally, the tweets being separate here has another benefit. If there's some sort of tweet service as we start to expand and maybe we hire more engineers, we decide that we want a tweet service to manage those. This allows us to make a microservice for this, because one of the key things, and you want to explain these things as you're going through an interview, is that a microservice should own its own data store. You shouldn't have two services that share the same one. This is a no-no. Because this gets very, very messy very, very, very quickly. No. The thing is separation. That's why you do microservices. So this should have its own data store. And if you've built it this way, you can make a tweet microservice without actually adjusting your data stores, which is amazing. It's called thinking ahead. All right, so we have our API. Now, there are a couple things that we have to think about. And this is when somebody's asking you about Twitter specifically, they want to know about fan out and fan in. Now, I'm going to sit here and say that as our current 500,000, we don't need to worry about fan out and fan in. Why don't we need to worry about it? Is because we have few enough users that the problem this solves isn't worth it. And so I'm not going to design against it, because this will be fine. This literally can just query the users and their tweets for everyone's. Now, this will break at a certain scale. Twitter had this break specifically. So this app API does the feed. The feed is when you open your app and you get like what people that you follow have tweeted. We'll do the feed. We'll do the user management. So when you go to your profile, user management, it will do all of that and whatnot. Now, at this point in the design interview, people are going to start asking you questions about your data store. All right, let's say that we've gotten a bunch of new users. This would be a question I would ask. We've gotten a bunch of new users, and now every single time you query the tweets for all your followers, it's laggy. It's laggy. And the very first and easiest way is that you add a cache in front of your databases. Let's say people don't tweet very often. If people don't tweet very often, this is a fairly good way of doing it. We could talk about this. Or another very classic one, and is the fan out and fan in. And we'll talk about why you have both of those in Twitter. So when you're going with designing Twitter, there's two problems. There are people who follow a lot of people, and then there are people who have a lot of followers. And actually, these are handled differently. So this feed, user management, followers, this is going to handle all of it. These are all stored in the user database. Pretty easy. Now, what happens is that you could put these in a cache. So let's say you want to cache my feed. You can say that my feed, this is the feed of Merrick. That's not what I wanted at all. My feed. Let's do this. Merrick's feed right here. I follow 6 people. And what you're wanting to do is you want to bring into this cache the tweets from the people I follow. And so basically what you're doing is you're caching my feed. This will be really easy. And now when somebody that makes a tweet, let's say I follow Russell. I do follow Russell. Russell makes a tweet and it's going to fan in. It's going to put it here. Or fan out. It's going to fan out. When Russell tweets, because Russell is super popular, it's going to fan out to everyone because it's going to go out. But that doesn't happen for everybody. So when Merrick tweets, because Merrick isn't, so Russell has greater than 5 million followers. So this is the fanning out. This is Merrick's feed. But when Merrick tweets, nothing happens. It just goes to the database where it would. And what happens is when I go to get my feed, I get the cached results from Russell, the fanned in, because Russell has so many followers that it now is impossible to just query everybody's, because at this point it would slow the whole machine down because so many people are asking for Russell's tweets. And this is where the fan out and fan in come in. Oh, Russell, don't follow me either. I found that Twitter is only... Also, good to see you, Russell. Twitter is only good for not productive conversation. I have some productive conversations. I also have fun on it because I've learned to enjoy it. I've never tweeted in my life until I had a YouTube channel. And I was like, you know what? I should be on Twitter. And then I found out that it's just a bunch of people flaming each other. So it's kind of fun. It is kind of fun. I'm enjoying it. I'm not mean. But, all right. So this is what they're wanting or going to expect from you. They're going to expect you to know this aspect of Twitter about knowing fanning in and fanning out and why you might need it. But the thing is, it's different because this is for Merrick's feed. But when Merrick tweets, it doesn't fan out to anybody. The tweet gets put in the tweet database. And when somebody that follows me, so there are a couple things when we get a GET request here. Man, I'm not explaining this very well. Like I said, when I'm in an interview, it's rough. GET request, GET feed. What it's going to do is it's going to take this cached with all the super popular people that, and I believe Taylor Swift was the person that actually forced this to happen. It's going to then also populate it with people that are small. Because getting Merrick's feed or, Tom Bombadil's, I don't know how to spell his name or pronounce it. Anyways, they don't have a whole lot of followers. Tom, unfortunately, is a fictional character. He probably has more followers than I do. BMB, Tom Bombadil. Anyways, so this is the whole premise of the fan out and fan in and how different users are treated differently. Okay, so that's a good one. How to come up with the number of followers to enable to cache for them. So to know whether you fan in or fan out is going to take experimentation. And if my interviewer asked me that, I would tell them that I can't. I'm not going to mathematically be able to tell you what our infrastructure is going to do. That's going to require some amount of experimentation. But what you could do is make your system where the number that you're shooting for, design the system so that the number is configurable. Make the number configurable. And this way you can update it as your system updates. I think Twitter said it was around 1 million people. We can Google that really quickly. When does Twitter large account switch to fan out? I know it's out there somewhere. See, Lady Gaga fans out because, yeah, you have to. I don't know what the number is. So it doesn't matter the number of people you follow. It matters who you follow more than the number of people you follow, right? Who is more important than what? Because it matters if the person you're following has a lot of people. So if they ask you about a Twitter app, they probably want microservices. They probably don't want this. So we're going to change this to, instead of 5 engineers, 50 engineers. And we're going to update this architecture to be 50 engineer architecture. And we're going to put this to 5 million with 500,000 expected growth every month. This is probably more likely what you're going to get. And this architecture changes quite a bit from what we've done. So we might still use an AWS load balancer, maybe. What I would do here is we'll probably move to microservices with 50 engineers. We're going to have a team that handles tweets. We're gonna architect this a little bit differently, and we're gonna work with some events. I like event-based systems. The cool thing here is we don't change our users. We don't change our data stores for the most part. We will be adding in some caching. Another thing that you can cache is a CDN is actually a cache of your front end stuff, which I hope people would know. If I asked what a cache or a CDN was, it's a distributed cache. That's what it is. That's like the easiest way to say it. If somebody's in a system design and asks you what the CDN is, it's a distributed cache. Now we can talk about how to make that distributed cache and dig deeper into it, but it's a distributed cache. All right. So we're designing this with 50 engineer team with 50 million expected users. Or let's do 100 million. 100 million. Yeah. 100 million expected users. 10 million a month growth. Let's design it a little differently. It will need it. First, we have our tweet database here, but we're going to talk about that a little bit later. We're going to make a image ingestion service here. Image ingest to Grumpington's comment. This allows us to scale this specifically, individually, whereas we wouldn't be able to. And this is going to be a heavy worker. So basically, this is going to compress the files. Heavy on the compute. Not only that, we have the requirement that we only upload food. We only upload food. Is this food? So we have an AI that sits here in our pipeline. We want to check if it's food before we work on compressing it. Okay. Now, for our tweets, we actually have a cache here. This is our feed cache. The feed is actually only a cache of the actual tweets. It could be rebuilt effectively. So we have our feed cache here that we're going to have. And we have our actual tweets. We're going to make this a tweet API here. Now, there's a whole lot that can go into this, because another question that comes up to mind right now when we're talking about this is, how do you handle hashtags? How do you handle hashtags? Now, they might want to know how Twitter did it, which is the easiest one to do. Read how Twitter handled these problems. They've blogged about them extensively. I'm not going to dive into the handling their hashtags right now, but we'll have a system for it. So basically, we can have a system that parses those hashtags. There's some really clever things they did. I would never have thought of them. That does that. So our tweet API is going to parse hashtags. And images. I'm going to say tweets only have images or text. I don't know. We're kind of digressing. I just wanted to show a little bit of a different one. It doesn't matter. We're going to have a tweet API, parses the hashtags, and then it saves it into the tweet database. But then it's also going to send it to something to fan it out. So if you're a popular person, basically there's going to be a do we fan out? And we'll make a system that does that. We'll make a fan out system. Over here. Actually, we already have one. And this can go here, or it can go here where we were going. Fan out is going to insert these things into this. And this is why microservices start getting kind of messy. So the tweet API, the feed, can go up through our WAF. All right. So we're starting to build this, but this requires a little bit more mess. Now you might be tempted to make this a little simpler, to add Kubernetes as a scheduler. I don't know if it's the right thing for your 50 engineers or not. Do you guys know Kubernetes? I don't know. You don't have to. It's still simple enough that you could have a sane Elastic Beanstalk deployment. You have a couple of things. This is a cache. So this is really just a deployment. This is actually a small fan out service, and you have your tweets being stored here. Now, I would say that we probably actually are okay here. We're going to put a user service over here to talk to our users. This is now the sole proprietor of the user database. Again, when you're talking about microservices, each microservice should own its data store. Whether it's a cache, whether it's a user, it's the owner. It makes it much more reasonable to think about. So if they're wanting to know their users and whatnot. Now, the thing is, do the users know what tweets they've tweeted? I would say generally the answer is no. They don't. All right, so we're starting to get a little bit of a microservice architecture going here. If the tweet has a image, it goes to the image ingress. If it doesn't, it goes straight down to a tweet. If it needs to fan out, it can fan out now. And we're still serving everything through the AWS CDN firewall and the WAF. Now, obviously, Twitter is bare metal, and we're leveraging S3 stuff here, but that was a question we asked. And so that's fine. If we said not bare metal, if we said bare metal, you can still just say WAF. You don't need to know that what WAF. We need a WAF and we need a CDN. Again, we can get into the specifics of how to design these specific systems. And usually a system design interview is going to dig into one of these things. They're going to ask you questions about what the WAF does and why. How would you design a WAF? Another great one that comes in here, rate limiting system. Anybody that's over 5-7 years, how do we rate limit this? Rate limiting is partially part of the WAF's job, but there's actually applicable reasons to rate limit somebody as well that are outside of the WAF. So how do you, in a monolith, the rate limiting is easy. You have a single service that limits the rates. But in a distributed one where you might have a bunch of these services, how would you rate limit that? And that's a very important question to be able to answer. Rate limit the number of requests. So let's say that a person can have 10 requests, let's say that they can do, let's do this. 20 tweets per minute. Maybe you put this in there because you don't want bots. And so this keeps you from having a bot that just spews out a ton of garbage and abuses your system. So you want to rate limit people to 20 tweets per minute. Now, a lot of the times, this is kind of just to what we were doing, but a lot of times rate limits go to cloud providers. So cloud providers will be like at your current level. AWS does this all the time. You have limits on how much you can request of a resource. And some of those could be rate limiting your API requests as well, saying you can only do so many. And this is to avoid abuse. So how many calls to an API per time unit? It could be seconds, it could be minutes, it could be hours, it could be days. That's a rate limit. Now, in a monolith, this becomes very easy. In a distributed system, this becomes very difficult because your requests could be coming through a different channel. A very easy way to solve a rate limiting. You know what? Let's add rate limiting. Do we have that as a design distributed system? We'll design a rate limiting system. We do have rate limiting. I thought of it. We'll do rate limiting. But there's simple ones. You could literally just have this as a cache. That's like the simplest one is a shared cache for the ingress. There's problems with this. There's actually a lot of problems with doing it efficiently because you could have millions of API calls. Per tweet is probably easier because that's not API calls. That is legitimate tweets, a specific API call. There's trade-offs. There's like different ways to design and there's trade-offs. A lot of API aren't perfect. So if you set the limit to 20 a second, it would be very expensive to be perfect. And so a lot of times there's a little fuzzy where it's like your rate limiting system might allow 26 per second or 22 per second, but it's going to at least allow 20 per second. So that's what you advertise, because one day it might fail at 22 a second and one day it might fail at 25 because it's a little fuzzy. But it will at least allow you to make 20 per second. And that's your most common style. So when you're doing these, it's good to bring them up. Even if you're not an expert on rate limiting, this is where you say, hey, I know that there's techniques to do rate limiting of APIs and to monitor those and do those. I'm not a perfect. I'm not super experienced with those. Your interviewer will know if you are or not. So just be honest. But we'll want a rate limit in here on top of the WAF. That's right, Russell. Russell, let's snooze that ad break. That was close. As you want to know how much traffic each public interaction causes so you can scale or more independently charge for API calls. This is an excellent, yeah. A lot of clouds and as a service things that provide an API worry about this because it's how much it costs them. Yeah. Hey, Russell, would you be willing to mock interview me and be tough in the future? Do like an actual mock interview. Cool. That would be awesome. I think it would be awesome. I'm not asking for today. I was just asking as a, in the future, if people would be interested, do some mock interviews. And I'll be the interviewee. I'm not a great interviewee. I'm surprised I get jobs every single day. But that would be awesome. All right. All right. So next week, we are updating the Eddington to the architecture we talked about here. We're going to be doing this with Ori to make this system suck less, the system that we currently have. So that's what we're going to do. We can also do, after we are done doing that, we can do another system design thing. Let me know which ones you guys would like to talk about, whether it's rate limiting, how rate limiting works. We can cover how rate limiting works. Or whatnot. Yep, would love to do it. But next Saturday, we're going to try to fix our Ori problem. We fixed one problem with it, where we were actually doing the Ori hooks and it was dependent on Ori, but now our app is still dependent on the Ori API, and we're going to try to do that remove that with ingress from Istio, which should allow people to not do this. This is where you have to have 4 tabs to run Eddington, because right now it's a massive pain. Yes, Crowder, Russell is 100% right. That's why I do these. And you know, this is actually one of the reasons I sometimes over-explain stuff where people are like, oh, get to the good parts faster, is because I don't know where people come from, and I try to make it very obtainable for anybody that joins, and I spend time explaining those things. I was in your spot just a little bit ago. Honestly, I am going to text Mac. Mac was the first person to hire me, and see if he would come and tell horror stories about the code that I wrote. Those people helped me. I was in the same place. Just a little bit of time ago, I would have had no idea as well. So yeah, don't worry. Ask questions, and everybody here is all about helping out. So yeah. Ask those questions, and that's why I did all of this, was so that hopefully it would help. Anyways, that was a basic Design X, what basic people would want. next time, let's actually design. We can design a CDN and cache and all these things, but I also would like to dig into, like, let's talk about designing a CDN. What needs do a CDN have? What are they responsible for? Rate limiter is a really good one. Pub sub and event-based systems are a really good one. And so we'll cover those. Honestly, so system design is really, really big. And this is where I don't think any interviewer expects you to know everything that they do. I might oddly know a lot about schedulers. I do. I didn't even talk about schedulers here, but one of the things I do know about is schedulers. But that's kind of the thing. Is in this, I probably would have at some point, if this was like a real interview, talked about schedulers because I want to show off things I do know about. And so it's important, and I think that most people would understand this, that we are not all experts on all topics. And so what a system design interview wants to see is how many of these systems do you know? And do you read the popular things? So do you know about Twitter's fan in and fan out? It's a pretty popular, understood thing. They want to know that you at least understand the base concept of it. I don't know everything about Twitter hashtags. Honestly, the hashtags one is one that I'd have to think about. We should design a hashtag thing. How do they incorporate that into the rest of the system? I'm not entirely sure off the top of my head. I do know that there's several blogs on it. I'm guessing they tokenize it somehow, but again, I'm guessing. And I would say, hey, in an interview when I'm having that, I'd be like, you know what? I don't know how Twitter specifically does this, but I imagine that they take that hashtag and they tokenize it somehow. And I'm pretty sure there's probably a standard way of doing it. I've never had to do that, so I've never actually done that. And now I've just conveyed that, A, I know the limits of my knowledge. I would go look it up. I'm going to go look it up after this stream now that we've brought it up. And two, they understand that I know the limits of my knowledge, but I also know a bunch of other stuff about it. I'm competent also that give me a day and I'll tell you some of the good ways. And I'll have a good idea on how we might handle it ourselves for our particular way of doing it. The CDN will be interesting for the locality calculations. Yeah, Russell, CDNs are actually really interesting because, like, they're really simple by concept. It's a distributed cache. Like, oh, okay, that's simple. But a real CDN is not so simple. So, ads are in progress. I'm going to I've been drinking this water. I'm on 2 cups. I have got to go. 1 second. Be right back. All right. All right. All right. We're back. All right. I have a serious question for you guys. As you all know, I am not good at I'm not good at the front end. But as Eddington requires a front end, the Null Cloud needs a good front end. I have to learn one. We've been playing around with Vue. Vue is the one, but I'm opening up a poll on, I don't think YouTube allows me to do this. So if you're on YouTube, I'm sorry, but I'm going to open up a poll and I'm going to ask you guys a question. All right. What? Oh, you know what? I can actually show this on screen, right? I think I can. Give me 1 second. I'm going to show this on screen. Like a pro streamer. All right. What UI framework to learn? Now, I know React and somewhat Next.js. I don't really want to use either of those. Okay? So, we're kind of using Vue. Vue seems nice. But a lot of people have said that Solid is awesome and kind of like React. And then there's Svelte. HTMX is not a thing. Okay. I tried HTMX. I thought I would love HTMX. I dislike it so much that I'm making a YouTube video on HTMX because I must be missing something. I worked hard. I was gonna do it in HTMX. I was like, this is my type of thing. A back-end engineer does front end. I'll use HTMX. And I hated it. And I have some reasons. I hate it from a back-end perspective, not the front end. I hate it from the back end. There are about 500 frameworks, aren't there? Yes. Well, this is why I'm giving you Vue, Solid, Svelte. These have the Merrick approval of I will care about learning. I'm going to give you guys 2 minutes. 2 minutes. Which one should we do the Null Cloud in? Again, right now it's all in Vue, but we don't have a ton. We could do something different pretty quickly. Maybe it's Vue, and that's great. We'll just leave it. But I ask because what are you guys most interested in learning yourselves? Because I'll be streaming it some. So hopefully you guys are interested in one of these. If it's other, let me know. Again, not HTMX. Not doing HTMX. If you don't believe me, I can show you. He wants to roast Angular. This guy. I don't want to learn Angular. Is that my bad? Like, this wasn't about popularity, because if it was going to be React. We could just do it in React and be done with it. This was not supposed to be a popularity competition. It's not. That is not what I meant for it. All right, who voted other, and what do you want it to be? What's the other? I need to know. You gotta type it in chat now. You gotta let me know who you are, so I can roast you. I'm just joking about the roasting. Oh, you want it to be in you. You, okay. People are liking Solid. Wait, are you guys picking solid just to make me rewrite it? Is that literally what happened here? I don't think I'm going to write the front end in Rust. You guys are terrible. You guys are terrible. You guys... Absolutely zero interest from you guys to actually learn solid. You just want to see me rewrite it. Astra. You guys are awesome. Okay. All right. Check this out. I did, just to prove to you guys, I have a script about why I don't like HTMX. Not joking. I disliked it enough to list out why. But it's not just a rant of why I don't like HTMX, because I probably wouldn't do that. I do want to understand it better, because I think that I have to be misunderstanding. Astra. I do think that I must be misunderstanding it. Oh, I didn't think about that on YouTube, Grumpington. Dang it, I'm going to release it in a video. It's not just to complain, though. The idea is that, like, I found something that seemed like a non-starter for me. And maybe there's something that people know that I don't that makes it fine. But, like, there's literally one thing that it does that just destroys API design for me. And so I struggle with that. I think I scrolled too fast for you to actually read it, hopefully. Because I actually thought that I would love HTMX. I thought that I would. But I ended up not liking it. I also don't know now whether you guys were actually serious about wanting to learn solid or not. I was actually seriously asking what you guys would like to do it in, because those seemed fine to me. And I got Angular and Astro. I shouldn't have asked you guys. That was a mistake. I mean, it's not serious now. It's not serious now. Just shove your JS and HTML in a file, call it JSX. Actually, yeah, dude. It's interesting. But you know what? With Tailwind, Russell, we can one-up that. Check this out. Check this out. I can one-up. You said shove your JS and HTML in a file. Check this out. I can one-up that. Check this out. Not this. Well, I actually kind of separated it out. You can also put your CSS in that same file with Tailwind. Doesn't this make it pretty? Doesn't this make it pretty? Oh, you could use channel points? I didn't realize I let channel points be used.
You could also do that with style blocks or style attributes. Do you want to know a really compelling reason why to use Tailwind? This is the best argument I've come up with yet. So the AI can do it for you. Check this out. If I go here and do a div, it does the stuff for me. Yeah. Check this out. Like, we can then go here and, let's see. We can go to new user. And look at this. It put the password field, and it's styled appropriately and everything. If it wasn't in here, it would have probably already worked if we had the right class for it, which is the same class as this one up here. So, you know what? It really doesn't matter, but I was trying. Okay? It made this button for me. I don't know. Okay, so you all know some UI. I have a problem with Vue's router that makes me want to pull my hair out. And I'm probably using Vue wrong, but whenever I look up the docs on the Vue router, this seems to be right. As you can see here, let's see. I have like this pages, and I kind of like the routes to be based off of that page, but instead I have to like manually input routes. And if I want a new route, I have to make a new route. And if I wanted a nested route, I have to do something crazy like this, where I have these main routes and then I have these sub routes that we can have. And so, like, you know, this is that sub route of apps. So like, that's how you get this, and this needs to be updated, but main, apps. But like, this is a lot of work to maintain, and I thought it could just do it off of the hierarchy. Like, maybe I've been spoiled by React Next, but I didn't think I would have to do all of this static file stuff. I mean, I suck at the front end too. And this is why I'm asking this as a serious question. This seems to me really nasty. Now, maybe it's because I think Vue really wants to be like a single page app. And so maybe I'm doing this wrong, where like I basically, I don't know. I'm doing something wrong. That's all I know. It's garbage. But that's what the Vue router says to do, so. Anyways, it is 2 p.m. I don't know. I didn't realize, I wasn't actually meaning it to be a meme. I was asking what UI framework you guys liked, because I was thinking. I also do dislike Tailwind, and I don't know if I can take it out at this point without like starting over, which isn't starting a whole lot over, but. Are there any front-end devs here? Russell, I consider you a front-end dev because you just don't suck at it. I know that you do a lot more than that. You're not a front-end dev. You just suck way less than the rest of us. Right. I know, Russell, that you're not. Like, the rest of us just really suck at it, okay? And you know what is the worst thing is, I feel like with Eddington, the only thing that's really holding it back at this point is like it just doesn't have a usable UI. Like, this is not a usable UI. You can't do anything. And so I just have to do it. And so I'm going to do it. I just wanted to, like, if I'm not going to do it in React and I'm going to actually learn something, I thought I'd like to try to pick something to learn. Now, Vue seemed like a good idea. I kind of like Solid and SvelteKit, or Svelte, maybe SvelteKit. Yeah. So I'm going to read whether we start from scratch and go with Solid or not. Solid looked good to me. And why Solid looked good to me is because it looks a lot like React. Also, it's blazing fast. It is look at that. Oh, yes. That is what we pick a front-end framework for. Vue is also really good. I have no idea what Inferno is. It's probably some PHP framework, if I had to guess. It's the only way I could guess that you're in an Inferno. If you look at it, though, this looks like React. I feel like I could learn Solid fairly quickly. Maybe. I went through their they have a pretty cool tutorial that I walked through this. I wish that it would allow me to change it to TypeScript. I only got to like 4. I haven't done the whole thing yet, but it looked pretty good, but so did SvelteKit. Svelte looks weirder than the rest. Like, it definitely looks weirder. I gotta learn one. I don't know yet. I'm going to be reading this week. It's probably going to be either Vue, Solid, or Svelte. You guys should let me know which ones you actually would like to learn better or understand better, because I'm going to have to do one, because Eddington has to have a better UI than it does. It has to have a working UI. Nothing's wrong with Vue. Nothing's wrong with Vue. I'm doubling down on I have to learn one. So then I was like, if I have to double down on learning one, like now's my I'm not going to learn 2 new ones. I'm just going to learn one. I'm going to pick one and I'm going to go with it. Vue's been fine. I don't like the Vue router, but I think there's options for the Vue router. So you know what? I'm going to go look and see if there's a better router that I don't have to manually do. No, Russell. I actually want it to be useful. Oh my gosh. No, we're not doing 10. People have spoken. Okay. Forget I asked. I do think I want to get rid of one thing. I want to get rid of the Tailwind. Which hurts because there's a lot of Tailwind. Tailwind seems fun and all, but it's making really messy stuff that. And you know what? Part of it's how I'm using Tailwind here. Like, if you go into and look at all of these, like, Really, I should be making more reusable components. Like this button should be a reusable component, which then maybe it wouldn't be as bad, but then I'm styling stuff in it. This is a bad example, but maybe it's how I'm using it. But yeah, to me, this is just incorrect. I'm repeating a ton of stuff over and over and over again. I'm just not a fan. I think it is faster, especially for me, but yeah, I'm good. Oh, I was showing this, but I wasn't showing it. If we don't use, should we just use components instead of CSS components instead of this? Actually, I gotta look up how Vue does it. That's like a Next thing or React. You should be able to do that in Vue too, though. That would make sense, right? I'll look it up. We'll do something. Probably not next week. Next week we are fixing what we have broken with the API, and we'll do some more questions. I'm going to stream some during the week. I don't know if I'm going to do the same streaming during the week. There's not a lot of people that attend. I don't know if it's the time or that it's short. I'm not sure. We're going to play around with it a little bit, see if we can make it more entertaining or easier for people to join. We'll see. We'll see what my middle of the week does. But that is it for me today. Let's find somebody to raid. Let's see. Also, be asking your questions, your interview questions, your system design questions. We'll be going over those. I need to find the software. You know how I find the software? I go up here and I go to Merrick Counts. Hello, stream. Software and game development. There we go. All right, get rid of you. There we go. All right, we have JBlow. Oh, that looks interesting. Casey writes some pretty hot takes on YouTube. I'm kind of now interested. Let's see if there's any Rust people going. Oh, Tim is streaming. All right, so Tim or JBlow? One per page. You guys are going to kill me. JBlow or Tim? Which would you guys like to see? Where's Tim go? Tim does like a lot of C++. He does his own game engine. Where did Tim go? Tim. Oh, no. Tim is here. Python and C++ is cursed. You know what? I'm actually really interested in what JBlow is going. Go check out Tim. I'm torn. I'm gonna support Tim. We're going to go with Tim. He does a lot of work. I'm gonna watch the recording of JBlow. Otherwise, we're gonna go see Tim. Thanks everybody for joining. Thank you so much for joining. I hope to see you guys next week. We'll do some more stuff and have fun. Have fun rating Tim. And I'll see you guys next time.